Hello my dear students, in this lecture we will see one more numerical on complex stresses topic. Now see, the question is here, question is written on your screen. The question is, at a point in loaded component, the state of stress is given by sigma x is equal to 270 MPa, sigma y is equal to 130 MPa, and tau xy is equal to plus or minus 40 MPa. Determine the maximum and minimum normal stresses and planes on which they act. Second, the maximum shear stress and its direction. Dear students, this question was asked in ESC, that is IES, Indian Engineering Services 2013 mains for 10 marks. Now we will see the solution. If the same question is asked in GATE examination, the question they will ask for 2 marks, and with similar pattern many questions they have asked for GATE examination also. Now see, at a point the state of stress is given as, let us say at a point, if I consider this point here, the sigma x is 170 MPa, positive means tensile, therefore sigma x, which is nothing but sigma x is nothing but 270 MPa. Again sigma y, again they have provided sigma y value positive, sigma y which is nothing but 130 MPa, positive tensile, positive means tensile, and tau xy is 40 MPa, right? On vertical plane clockwise shear, anti-clockwise shear, and on horizontal plane clockwise shear. Likewise, this is tau xy, and tau xy they have provided 40 MPa, 40 MPa. Plus or minus means on horizontal plane if it is plus, then on vertical plane it will be minus. That is clockwise and anti-clockwise shear. Now the question is the maximum and minimum normal stresses and planes on which they act. Now for this, how to find maximum and minimum normal stresses? That is sigma 1 comma 2 is nothing but sigma dash plus or minus tau max. This is the formula, sigma dash plus or minus tau max. Sigma dash is nothing but normal stress on tau max plane, and this is tau max is maximum shear stress, which is nothing but sigma 1 comma 2. Sigma 1 comma 2 is nothing but sigma dash is sigma x plus sigma y by 2 plus or minus tau max is under root of sigma x minus sigma y by 2 whole square plus tau xy square. This is how we have to find. Therefore sigma 1 comma 2 is equal to sigma x is 270 plus sigma y is 130 divided by 2 plus or minus under root of sigma x is 270, sigma y is 130 divided by 2 whole square plus tau xy is 40 square, right? Now here, while finding sigma 1, we have to find maximum value, that is plus, we have to put plus sign, and while finding sigma 2 we have to put minus sign, right? If you solve this, sigma 1 comma 2, you will get 200 plus or minus 80.62, right? Now therefore sigma 1 is equal to 200 plus 80.62, which is nothing but 280.62 megapascal MPa. This is the maximum normal stress, which is nothing but sigma max. And while finding sigma 2, we have to put negative sign, 200 minus 80.62, which is nothing but, if you calculate this, 119.38 MPa, which is nothing but minimum normal stress, sigma minimum. And the under root term, which is nothing but, in this formula, sigma 1 comma 2 is equal to 200 plus or minus 80.62. This 80.62 is nothing but maximum shear stress, tau max. Therefore tau max is nothing but this under root term, or this 80.62 MPa. This is the maximum shear stress. But maximum shear stress they are asking in second question. Again they are asking the plane on which these stresses are acting, right? Now first of all, we have calculated principal stresses sigma 1 and sigma 2. Now we will calculate the plane on which they are acting, the plane on which these principal stresses are acting. These also we have to calculate, right? Therefore we will calculate the planes on which sigma 1 sigma 2 is acting, as well as the plane on which maximum shear stress is acting. Now we know that while finding plane, we have formula tan 2 theta is equal to 2 tau xy divided by sigma x minus sigma y. Now put in this formula. Therefore 2 tau xy is 40 divided by sigma x is 270 minus sigma y is 130. Now therefore is equal to 80 divided by 140. Now therefore 2 theta is equal to tan inverse of 80 divided by 140. Therefore from this you can calculate theta. Therefore theta is equal to, you will get 14.87. Simple calculation you have to do here. 14.87 degree. This is nothing but angle of major principal plane. This is angle of major principal plane with vertical in anti-clockwise direction. This is very important, in anti-clockwise direction. Let us say in diagram, if you see in diagram, let us say this is the plane on which sigma 1 is acting. Therefore theta is angle of inclined plane or major principal plane with vertical in anti-clockwise direction. Again, if you add 90 degree in this formula, if you add in this theta, if you add 90 degree, then you will get angle of minor principal plane. Therefore theta plus 90 degree, which is nothing but what you will get, 104.87 degree is the angle of minor principal plane. Minor principal plane with vertical in anti-clockwise direction. Again, in this theta, if you add 45 degree, then you will get 59.87 degree, which is nothing but angle of first tau max plane. First tau max plane with vertical in anti-clockwise direction. Again, in this theta, if you add 45 plus 90, then you will get 149.87 degree, which is nothing but angle of second tau max plane. Angle of second tau max plane. This is how we have to find angles. Right. Now if you want to show diagrammatically, for this, what we will get, let us say in this component, if I consider this component, in this component on a plane at angle theta with vertical in anti-clockwise direction, with vertical at angle theta is nothing but 14.87 degree. On this plane, the normal stress acting is sigma 1. Therefore this is major principal plane. Right. And on any principal plane, shear stress is 0, that is parallel stress is 0. Right. At 45 degree to this major principal plane, there will be a first tau max plane. Means on this plane the maximum shear stress is acting. This is called first tau max plane. Right. On this plane the maximum shear stress is acting, and on this tau max plane the normal stress of magnitude sigma dash, which is nothing but sigma x plus sigma y by 2, is also acting. Right. Which is nothing but 200 in this given case, 200 MPa. Right. Again, add 45 degree to this, right, means perpendicular to major principal plane, there will be minor principal plane. That means on this plane sigma 2 is acting, normal stress is sigma 2, and again on this principal plane shear stress is 0. On both principal planes shear stress is 0, and from this minor principal plane again add 45 degree angle, there will be second tau max plane. Means on this plane the maximum shear stress is acting, the shear stress is tau max, and again on this plane the normal stress is sigma dash, which is nothing but sigma 1 plus sigma 2 by 2. Right. This is how we have to locate the planes. Thank you, dear students. In next lecture we will see one more previous year IAS numerical which was asked for complex stresses topic.